Hello there, algebra students. Mr. Lawrence here, and Riley Goulis had asked me to make a video explaining domain and range for exponential functions. And so I'm going to do that. It should be a quick video. So Riley, here you go. This will be the last video I make because it's already 4:15 on Sunday, and I have other work to do, so I won't be able to make any more videos. All right. So here's a table, an input-output table, and the equation. Uh-oh, we're not working. The mouse is not working. Let me try it now. Nope. Okay. Sorry this is taking so long. Let's see here. Connected. There we go. Okay. So the equation, or the function, was y equals 2 to the power of x. Okay. Now I went ahead and graphed it using Desmos because we're trying to find domain and range. And let's see, this is it here. Y equals 2 to the power of x. Now if you look at the domain, we're looking for the possible inputs, the x values. Well, we can obviously see that x can be -10 or -8 or -6. Can x be a much smaller number like -100? Well, zooming out will show that sure enough it can. Look, there's -300 turning red, right? And we can go out and out and out, and we're at -5,000. So we can assume that this graph is going to continue this way forever. Now, you notice here, it doesn't appear to be going vertical, does it? It's moving to the right a little bit, not as quickly as it's moving to the left, but it's moving to more and more positive numbers. Like, let's see, what's this value right here? The x-coordinate is 5.171, so we know x can be 5. All right, it can be 5.25. Well, if we keep going, this thing will eventually cross 6. I think it's crossing 6 somewhere around here. Let's see. Oh, wow. Okay. There it is. It's crossing 6 right there. Okay. So it's going very steep, but it is getting larger and larger and larger in the x direction. So the domain for this will be all real numbers. Now the range is actually very, very easy. You see, there's no red down here below the x-axis. And remember that the x-axis is where f of x, or y, equals 0. Watch, oh, it won't let me do it. Okay. But this is the point 0, 0, -2, 0, -4, 0. And we know that it doesn't hit the x-axis. It only looks like it does, because when we zoom in, we see it separate, right? So we know that there's an asymptote there. Where's the asymptote? Well, it's at f of x equals 0. If we go back here to the input-output table, we see that the fractions are getting smaller and smaller and smaller as the input is negative. We'll get, for -4, we'll get 1/16, then 1/32 for -5, and then -6 would be 1/64. They're getting smaller and smaller and smaller. They're approaching 0. So that means that the range is going to be all real numbers such that f of x is greater than 0. It can't be 0 because the graph will never touch where f of x is 0. It's just get very, very close to it. Okay? So the domain was all real numbers and the range was all real numbers such that f of x is greater than 0. Now here's a similar one, similar equation. This time it's y equals 2 to the power of x plus 1. Okay, and let's go ahead and take a look at the graph. So let me get it. I've already got it graphed. Where are you, Desmos? Oops, didn't take it. Okay, and so let me go here. All right, y equals 2 to the power of x plus 1, or f of x equals. Now, it looks like the same graph, only it's up higher. See, it's not approaching 0. And if you went back and look at the t-table, the input-output table, where are you? Okay, look, it's not approaching 0. You got 1.5, 1.25, 1.125. Then you'll have 1 and 1/16, 1 and 1/32, 1 and 1/64. It's approaching 1. by the way, this is not a coincidence. This is not a coincidence that there's a plus 1 here. Okay? So the domain is going to be just the same, all real numbers. The domain is going to be all real numbers, just like in the last graph. The range is so simple. The range is going to be all real numbers such that f of x is greater than 1. Yeah, all the y values in this input-output table will be greater than 1, guaranteed. All right, one more and then we'll wrap up the video. Here's an input-output table, and this one is supposed to be y equals 2 to the power of x minus 3. By the way, I hope you can read this. This is supposed to be 2 7/8. Typing in Smart Notebook doesn't really work. That's negative 2 3/4, etc. Okay, now hopefully you can tell what the range is going to be already, but if you can't, let's go ahead and take a look at the Desmos graph. And there it is. Ooh, it looks like it's about the same thing, only it's dropped down below the x-axis now, and it looks like the values are getting close to negative 3. F of x is negative 3, and look, it says minus 3 right there. Again, that's not a coincidence. So, doing domain and range. Okay, domain again is all real numbers. The domain is going to be all real numbers. The range this time will be all real numbers such that f of x, or you could use y, is greater than negative 3 every single time. Now, in the case where the graph would open like the other way, let me see if I can get one to show up here. Let me minimize that. Let's go to Desmos. There we go. Okay, let me change this, and let me go with negative 2 to the power of x. And let's go with plus 2. See, the asymptote is still at f of x equals 2, or y equals 2. It's approaching 2, but it's approaching it from the bottom, okay, from underneath. So the domain would be all real numbers. The range would be all real numbers such that f of x is less than 2, see, because it's approaching it from underneath. So all the y values for the graph are below 2. All right? Riley, I hope that helps you out. I'm going to call it quits there and go get my other work done. Good luck to you in your last minute studying. Mr. Lawrence signing off. Have a good night, everybody.